This is a re-upload of part 1 of my first Godot tutorial, because I wanted to correct an important mistake about object lifetimes. If you've already seen part 1, feel free to skip ahead to part 2, where I'll explain the mistake at the beginning. But for now, back to part 1. Today I'd like to walk you through the basics of creating a simple game in Godot from scratch. The plan is to create a platformer, where pieces of the platforms themselves will fall down and be deadly obstacles. In future videos I plan on procedurally generating the levels, but this first video will stay pretty basic. Let's create a new project. I'll call it Crumbling Towers. Let's start with a really quick tour. Along the top we've got our main views, 2D, 3D, script, and the asset library if you want to find reusable code that other people have provided. We're only going to be using the 2D and script views for this project. Over here on the left will be a hierarchy of all the nodes that make up the scene. I'm going to go ahead and create a root node to start with, and I'll call this in-game. The file system is pretty self-explanatory. Over on the right we can get details for the currently selected node, and we'll come back to this node tab later. There are a few things I like to do up front with a new project. First, I'm going to set up snapping to a grid. In this case, I think I'll use 16 by 16 pixel increments. To enable snapping, we'll also have to click this button, and to see the grid, we'll have to enable it from the View menu. Next, let's go into Project Settings and set the window size. By default, nothing gets stretched when you resize the window. I'm going to set this to 2D mode, which does a smooth upscaling, but viewport is better if you want to work with pixel art. I'm also going to set the aspect to keep, so the aspect ratio won't be changed by resizing the window. Alright, let's create a node to hold all the level objects. I'm choosing a node 2D because that's the most basic type that has positional information, and I want to be able to pan the level up and down. As long as I place the level objects inside level on the hierarchy, they'll move along with it. Eventually, in part 2 of this tutorial, we'll be placing the level objects procedurally through code, but for now let's place some things manually so we can start building the mechanics. I'll start with the ground, but first I want a sprite for it, so let's pop over to an image editor real quick and make one. I could create this the same way I have been, but for sprites there's a shortcut. You can drag and drop an image, and it will create a sprite node underneath the currently selected node. The ground will also need a physics object. There are several types to choose from, but for an unmoving object, a static body 2D is probably the best fit. I'm actually going to make the sprite a child of this. It doesn't really matter for this object because the ground doesn't move, but it's a good habit to make the visuals a child of the physics object, so that when physics cause something to move, the visuals move with it. Now it's already warning me that I don't have a child node to define the shape of this physics object, so I'll go ahead and add that now. In this case, I'll use a rectangle and resize it to fit the sprite. If you don't want this blue highlight, you can make it invisible and it will still work. Alright, let's move on to the player. Once again, I'll make a quick sprite for it. Now for the physics object. This time I'll use a kinematic body 2D. If you want to do a physics-heavy game where everything is done by simulated forces, you'd want a rigid body 2D instead. But kinematic body 2D ignores forces to give us more direct control over movement. The downside is we'll have to do a little more work ourselves to get it moving. But first let's make sure the sprite is nested inside the physics object, because this one actually will move. And let's make sure the physics object and sprite are in the same place. Now let's add a shape to match. This time I'll use a capsule shape. In order to move this parent node without accidentally selecting something inside it, we can switch to move mode so that clicking things in the 2D view doesn't select them anymore. Now let's rename some of these nodes so it's easier to tell what's what, and attach our first script. By default it'll have the same name as the node. So Godot gives us a bit of a template. As you can see here, ready is called when an object first enters the scene, and process is called every frame. The underscores on these function names are a clue that they're special functions Godot calls automatically. These hash marks are for comments. Basically everything after the hash mark is there for you to read and doesn't have any effect on what the script actually does. I'll keep the programming lessons to a minimum in this tutorial, but I can go into more depth on that in a future video if there's enough interest. Physics is a bit special because it runs multi-threaded at the same time as other code. In order to play nicely with that, we need to do our physics work at a separate function called physics process. It takes one parameter for the amount of time that's passed since the last time it was called. To start with, let's do a bit of gravity. To accelerate over time, I'll need to store a velocity value, which will be a vector too, so it has both x and y components. Each frame will accelerate in the y direction, factoring how much time it's been accelerating. We have a few options for how to apply this velocity, but I'll be using move and slide, so that in the future when we bump into objects mid-air, we can keep moving in a natural way. But it's worth reading the documentation on the other options in Kinematic Body 2D. It's important to note that this particular function, unlike move and collide, uses velocity and not distance for the move. There are some other optional parameters we can add, and I'm going to use one of them for the floor normal. This indicates a direction perpendicular to the floor, pointing up, so that the engine can do some work for us in telling us whether we're on the ground or not. Now the benefit to the slide part of move and slide is it returns a new velocity, which, when you hit an object, subtracts out the part that continues to push into that object and keeps the rest. So what happens if we run this right now? Let's click the play button, or you can hit F5 if you're using Windows, and let's go ahead and save the scene. And he's falling way too slowly. That's okay, game development is a lot of trial and error. And apparently I haven't set the main scene yet, so let's do that. There, much better. Now let's add some controls. The quick and dirty solution is to just check what keys are being pressed directly, but the more elegant way if you want to handle multiple kinds of input is with input mapping. In project settings under the input map tab, let's add 3 actions for move left, move right, and jump. And for now, I'll just assign keyboard keys to each. Now back in the script, we need to implement another special function called input. It takes one parameter, an event, which has all the information we need to know what type of input we got. First, we should check which action it is, if any. Keep in mind, input gets called for other things too, like mouse movement. Now I've done some experimentation already, and found out this works better if I don't just set the velocity directly. Instead, I'll store the intended x velocity and reapply it every frame. When letting go, I only want to zero out the velocity if we're still moving left, because the player could have more recently pressed the right key. Now let's just do the reverse for move right. Now let's actually apply that velocity and run it again. Okay, we're getting somewhere. Now let's flip the sprite when we change directions. But first, let's rename the sprite node. We can get a reference to it in our script by using getNode and supplying the name of the node, but there's a shorthand using $. And let's run it again. Alright, now let's try a jump. Once again, instead of setting the velocity directly here, I'll remember the intent and apply it during physics process. This is where that floor normal comes in handy, because we can now check is on floor to only allow jumping when we're standing on something. Now we could set jumping to false as soon as a jump occurs, but I found it a lot easier and more fun to play if I allow you to keep jumping every time you touch the ground while spacebar is held. So to stop, I'll just add a little code in the input function. Now let's try it out. That works. Back in the 2D view, let's create a new node for a platform, this time a rigid body 2D, because I think it would be cool to see the physics fully simulated as they fall. And it's time for another quick and dirty sprite. And let's put in a collision shape to match. And let's run it. Oh dear. Well, that's not ideal. Let's just make it a kinematic body for now, and we can come back to rigid bodies in another tutorial. Luckily, Godot lets you change the type of a node in place. And let's change the name so we don't get confused. Now what if we want a bunch of these platforms? We could duplicate it over and over, but then if we want to change something, we'd have to change each copy of it one by one. This is where scene instancing comes in. Everything here is just one scene right now, but you can actually have a scene within a scene. For those familiar with Unity, you can use scenes kind of like prefabs. Conveniently, I can just split this existing node off into a new scene. Now if I duplicate this, or add an instance of that scene, I can just go to the platform scene and make changes that will apply to all of them. For a basic platformer, we're getting pretty close to finished. Although it looks like I can't quite fit through a one-tile gap, so let's shrink the collision shape on the player just slightly. Much better. There are a few more things I want to add before wrapping up part 1 of this tutorial. First off, let's add a goal. And for this, another quick sprite. Okay, super basic, but it'll do the job. Now I want something that interacts with the physics to let us know when the player touches it, but we don't need this to be a solid object. So instead of a static body, let's just use an area 2D. As before, we'll align the sprite with the physics object, and add a collision shape. So how do we know when the player touches this? Well, let's finally take a look at this Node tab. Godot uses signals as a mechanism to call into whatever code you want when certain things happen. First, we'll have to attach a script to the goal. And then we can connect the body entered signal to that script. Godot adds a function template for us automatically, but now we should decide what we want to happen when the player reaches the goal. To keep things simple for this tutorial, I think I'll just put an image on the screen and a button to proceed to the next level. And for that, another quick and dirty sprite. Let's move this one directly under the endgame node so it stays in the middle of the screen even if the level has shifted. And I'll just center it real quick. So initially this should be invisible, but we can make it visible from our script. Now we could reach this in the hierarchy by calling getParent a couple of times and then getNode, but in case we change that hierarchy later, let's make a path from the root. Unfortunately, I don't think we can use the $ shorthand here. Let's try it out. And now I'll add a button underneath that so it becomes visible at the same time. I'll temporarily make it visible again just so I can see what I'm doing. Now let's name this and attach a script. Normally we use signals for interaction with UI controls, but there's a shortcut for buttons. If you just implement a function called pressed, again with an underscore, it'll get called automatically when the button is pressed. But how do we get to the next level? Well, first let's split level out to another scene like we did with platforms. We can now load that scene into a constant so that we can reference it and create a new instance from code. But first let's remove the old level. Calling queueFree will delete the object at the end of the frame. Deleting it during the frame can lead to problems because it's still in use. Then I'll create a new instance of the level scene, add it as a child, and hide the level complete message. Right now there's only one handmade level, so we're just reloading that. But when we add procedural generation in part 2, we'll get a new level every time. Next, let's pan the level so that it follows us as we move higher. To make this easier to see, I'll add a few more platforms to the level. Now let's add a script to that root level node. And we'll update the position in process. Because we'll be progressing upward, I want to show mostly what's above us, so I'll position the player about 75% of the way down the screen. However, I don't want to show anything below the ground. And that works. Now, as our last step for this video, let's make those platforms able to fall. Going back to the platform scene, let's add a script. First off, we need to know how long before it will fall. I'll use -1 as a special value to mean that this platform does not fall, and I'll make that the default. Now we need to know how much time has passed, but I don't want to start that timer until the player moves. So I'll be spreading this work across 3 different scripts. First off, the level will track whether or not the time has started. Then the player script will set that to true the first time you move. We should probably track the elapsed time in the level, so we don't have to repeat this inside every platform. And lastly, the platform script needs to check that time and react accordingly. We can copy-paste some of our code from the player for handling gravity. To try this out, we'll need a way to set a non-default value for the time until fall on some of the platforms. For now, we can make this manually editable for each instance by adding an export keyword. So now when I select these platforms, you can see the time until fall variable is editable right here. I'm going to set this to 3 seconds, and this one to 5 seconds. Let's try it out. There it goes. I'm seeing some slightly glitchy behavior as they land on other platforms, but I actually don't want them to collide with each other, so let's take care of that now. You can control what collides with what with the layer and mask. The layer decides what group the object is in, and the mask decides what groups it will collide with. I'll leave platforms in the first layer and move the player to the second. Now the platforms will only collide with the player. Let's try it out. I wasn't actually expecting them to stop on the ground, but I'm okay with that. Now let's make it so you lose if one of these hits you while it's falling. To do that, let's go back to the platform script. After that move and slide, we can find out if there was a collision and get the specifics if there was. That 0 parameter means I'm getting the first collision if there are multiple, but the only scenario we care about, when it's falling through the air, should only be hitting one object at a time. I'm checking the normal here because I only want it to count if it's falling on you from above. So what happens when you lose? Let's do something very similar to what happens when you win. I'll whip up another quick sprite. Let's just copy this win node and change it. To keep things simple, this button can behave the exact same. I'll just change the label a little. However, win or lose, we should probably stop the player from moving until they start the next level. For that, I'll go back to the level script. Let's set level done to true when we either win or lose. Now I can copy paste, and I need to make sure to show that game over message. I'll also need to disable player input once the level is done. As intended, I can't move anymore. However, this button isn't clearing the game over message. It turns out the reason is the level isn't actually destroyed until the next frame, so the collision check happens again and sets visible to true again after I've clicked the button. A quick and dirty solution is to just set time until fall to -1, so we stop running this code. With the core mechanics implemented, I'll call this the end of part 1. I've already started working on part 2 where I'll procedurally generate the levels. However, it's taken me over 8 hours just to edit the footage for this part, not including any of the time spent recording it. So I've run out of time to go any further this week, but hopefully the next one won't take as long. I hope this has been helpful, and if you'd like to support what I do, please spread the word about this channel. I'm considering starting either a Patreon where patrons can vote on what topics I cover next, or running a Kickstarter for a game I'm working on called Cargo Defense. But I'm not ready for either just yet. But if you'd be interested in either of those, please let me know in the comments. Meanwhile, if you haven't already, please consider subscribing. And as always, thanks for watching.